So continuing on with graphing quadratic equations, I'm doing another example. So if we want to graph y equals x squared minus 4x plus 7, we can first find the vertex. And the x-coordinate can be found using the formula opposite of b over 2 times a. And so the value of a is 1, and the value of b, the coefficient of the x, is negative 4. Right? The number in front of the x squared is the a. The coefficient of the x, that is our value for b. So the opposite of b is negative 4, the opposite is positive 4, over 2 times 1. So 4 divided by 2 gives us the x-coordinate of 2. Once we have the x-coordinate, we can substitute that back into our equation to find the corresponding y. So that's 2 squared minus 4 times 2 plus 7. So 4 minus 8 plus 7. 4 minus 8 is negative 4, plus 7 is 3. So the vertex of our parabola is going to be at 2, 3. Okay, so I'm going to go ahead and place that on the graph at 2, 3. To find the y-intercept, we're looking for where our graph or where our parabola will cross the y-axis. So we know that the x-coordinate is going to be 0. So substituting 0 in for the x-coordinate, we have y equals 0 squared minus 4 times 0 plus 7. So that tells us that the y-coordinate of our y-intercept is 7. So y-intercept at 0, 7. So 3, 4, 5, 6, 7. And again, we can go ahead using our axis of symmetry to see that if there's a point, if there is a point here, 2 units to the left of the axis, there should be a corresponding point 2 units to the right. And we can see that our parabola looks like this. So we were able to make the graph without even finding the x-intercepts. And if you look at the graph, you see that there are none. We have our vertex here, and the parabola opens up. And so this parabola isn't crossing the x-axis at all, so therefore it has none. Okay? If you were to start, doing the algebra to figure out the x-intercepts, so let's say you didn't have the graph in front of you and you were just working through the algebra trying to find x-intercepts, you would still substitute 0 for y and solve to find the corresponding x. So in this case, if we put 0 in for y, we have 0 equals x squared minus 4x plus 7. This isn't factorable, so we can either solve this using the quadratic formula or by completing the square, either way. If we use the quadratic formula, we have a is 1, b is negative 4, and c is 7. So we get x equals opposite of b plus or minus the square root of b squared minus 4 times 1 times 7 is 7. So a times c is 7 all over 2. So we have 4 plus or minus the square root of 16 minus 28 is negative 12 all over 2. And just looking at what we have here, if we take the square root of a negative number, we get the square root of negative 1 is I. So when we substitute 0 for y, the values for x are complex numbers. Okay, these are complex numbers. This, when we're graphing in the real plane. So if you end up getting complex numbers, when you're looking for x-intercepts, that means that there are no x-intercepts, that the graph is not going to cross the x-axis. Okay? So you can look at it visually, and you can also check out the algebra and make sure that all gels. So in general, whoops, I already had that. When you're working with quadratic equations and you're trying to decide whether or not you're going to have any x-intercepts, if it'll be 1, 2, or none, if you're dealing with a situation where your vertex is above the x-axis and the parabola opens down, so visual here, if your vertex is above the x-axis and the parabola opens down, then that parabola has to cross the x-axis twice, which means it's going to have 2 x-intercepts. If it's that the vertex is above the x-axis but opens up, so same basic scenario, above the x-axis but opens up, you can see visually that it's not going to cross the x-axis, which means it doesn't have any x-intercepts. If your vertex is on the x-axis and either opens up or opens down, and that was a bad picture, it's only going to have one x-intercept, and the x-intercept is going to be the vertex. So the vertex and the x-intercept will be one and the same. If you have a vertex that's below the x-axis and it opens down, it's not going to cross the x-axis, which means it's not going to have any x-intercepts. And then finally, if you have the vertex below and your parabola opens up, it will cross twice. So we talked before about the fact that you can either have 2, 0, or 1, 1, 0, or 2 x-intercepts, and these would be the situations where you would have 0, 1, or 2. Okay? So we've been talking about graphing quadratic equations that are in standard form, and now we're going to talk about how we can graph if we're given this equation in this form here, this y equals a times the quantity x minus h squared plus k. Yes, you could take this right-hand side and simplify it so that you have it in standard form, but that's a lot more work than needs to be done. When you're given a quadratic equation that is in this form, it is always going to be that the x-coordinate of the vertex is this number h, or whatever makes inside of the parentheses equals 0. So if this was x minus 2, the x-coordinate of the vertex will be 2, because 2 minus 2 is 0. And then that makes this the y-coordinate, because if you substitute this number in, h minus h is going to be 0, squaring 0 is 0, 0 times a is 0, plus k, that makes this number here the y-coordinate. So it's always, when you've been given the equation in this form, the x-coordinate of the vertex is the number that makes inside the parentheses, no matter what is out here. It's the number that makes inside of here equals 0, and then the value for the y-coordinate is going to be then just k. Finding the y-intercepts and the x-intercepts, that doesn't change. The method that you use doesn't change when your quadratic equation is given to you in a different form. It's still going to be that if you're looking for the y-intercept, that you're going to substitute 0 for x, and if you're looking for the x-intercept, you're going to substitute 0 for y, and then solve to find the corresponding x value. So let's look at an example. If we want to find the vertex and intercepts to graph this, so here we have y equals x minus 2, quantity squared, minus 1. So the x-coordinate is going to be the number that makes inside the square part, inside the parentheses, equals 0. So the x-coordinate of the vertex is 2. If we substitute 2 back in, then we get 2 minus 2 is 0. Squaring that is still 0. Minus 1 is negative 1. So the number that makes this equal 0 is the x-coordinate of the vertex, and the number that is here is the y-coordinate. So our vertex is at 2, negative 1. So right 2, down 1. Finding the y-intercept, we're going to substitute 0 for the x and solve to find the corresponding value for y. So if we put 0 in for x, we have y equals 0 minus 2, quantity squared, minus 1. So the 0 minus 2, that's negative 2. And if we square negative 2, we get positive 4, and 4 minus 1 is 3. So our y-intercept is at 0, 3. Again, we can still use the same thing. Our axis of symmetry is this vertical line. Okay, the equation of that vertical line is x equals 2. You may be asked to write the equation for your axis of symmetry. Anytime you have a vertical line, the equation is always x equals a number, because a vertical line describes every point in the plane that has the same x coordinate. So since this line is through 2, negative 1, I know that this, and you can see it visually, that line represents all the ordered pairs who have an x coordinate of 2. But anyway, back to graphing. So if we know we've got a point 2 to the left there, we've got another 2 to the right here, and so we can, at that point, graph without even actually finding the x-intercepts. But to find the x-intercepts, again, we're looking for a place on the x-axis. So we substitute 0 for y, so put 0 in for the y, and we have 0 equals x minus 2, quantity squared, minus 1. And from what we were talking about in the early part of this chapter, when we have an equation that can be in the form something squared equals a number, they're very easy to solve. So based on this, if I add the 1 to both sides of the equation, I'm going to have 1 equals x minus 2, quantity squared, or I have something squared equals a number. And so I can solve by taking the square root of both sides. So if I take the square root of both sides, I have x minus 2 equals the square root of 1 is 1, so we've got plus or minus 1. Solving for x, we're going to add 2 to both sides. So we have x equals 2 plus or minus 1. No i's or roots. I can do the math. 2 plus 1 is 3. 2 minus 1 is 1. So this tells me that I have an x-intercept at 3, 0 and also at 1, 0. And if I place my x-intercepts, I see that it all seems to gel, that symmetry exists, and the x-intercepts make sense with the ordered pairs that I've already found. So connecting to make your graph. So if you're given this form, just something to point out, if there is a number in front that doesn't have any effect on the x-coordinate. So let's say, I gave you y equals negative 3 times the quantity x minus 7, quantity squared, plus 2. The x-coordinate of the vertex is 7. Okay, it's the number that makes inside the square part equal 0, and 7 minus 7 equals 0, therefore that's the x-coordinate. Having a number in front or a negative in front, that doesn't do anything to change that. It's the number that makes inside the parentheses equal 0. Okay, going back to this, same as before, when we were working with standard form, it's still going to be the case that if a is a positive number, then you know that you should end up with a parabola that opens up. And if a is a negative number, then you should end up with a parabola that opens down. So just, some things to think about as you're going through. Let me know if you have any questions. Good luck.